Welcome back to another deep dive, listeners. Today we're tackling some pretty foundational stuff. We're going to be acting as philosophers, or at least exploring what that really means. You know, those really big questions like what is knowledge? How do our beliefs work? What are our obligations, really? And even how we reason itself.
This is the kind of stuff that keeps you up at night.
Yeah, exactly. And, just like a good mechanic needs the right tools, philosophers have developed their own set of, conceptual tools to really dissect these ideas.
And some pretty powerful tools they are, too.
Right. And today we're focusing on one in particular, multimodal logic. Now, this might sound a bit intimidating, but honestly, it's a fascinating way to look at these big questions. And luckily you, our awesome listener, sent us a bunch of sources that really highlight how useful this kind of logic can be. So big thanks for that.
Yeah, those sources were a goldmine. And they really show how multimodal logic lets us go beyond just thinking about, say, knowledge all by itself. It gives us a way to look at how knowledge interacts with our beliefs, with our obligations, even with time itself. And that's where things get really interesting, especially if you're trying to act as a philosopher.
Okay, so let's break down this idea of multimodal logic a bit. It sounds like we're talking about logic, but with a twist, right?
Absolutely. The multimodal part is key here. It means that instead of having just one type of logical operator, like the ones that express things like it's necessary that or it's possible that, you actually have several.
Okay, I'm following. So like more tools in the toolbox, so to speak.
Exactly. So you might have one operator for agent A knows that, another for agent B believes that, maybe even one for it's obligatory that, and even one for in the future it'll be the case that.
So we're not just limited to talking about whether something is true or false, but we can add all these extra layers of meaning.
Right. And this is super important because, as Dana Scott, a big name in logic, argued, to really understand these complex philosophical ideas, we can't just study them in isolation. Like knowing what knowledge is one thing, but how does it relate to belief? How does it change over time? Those are the questions that really matter when you're acting as a philosopher.
And that's where multimodal logic shines, right? Because it lets you create these intricate logical systems that can handle all these different facets at once.
Exactly. Multimodal systems let us reason about different possible worlds, which are kind of like alternative realities. And we can see how the truth of a statement might change depending on what's known, what's believed, or even what's required in those different worlds.
Oh, that's a cool way to think about it. Like, reality as we experience it is just one possible world, but there are countless others out there where things are different.
Exactly. And that's so important for philosophy because it lets us explore all sorts of what-if scenarios and see how our ideas hold up.
And one of the really neat things that you can do with multimodal logic is uh, define one concept in terms of others, right? Like, how do we even define what knowledge is? Is it just a matter of having a true belief that's also justified?
Yeah, that's a classic example. Philosophers have been trying to pin down the definition of knowledge for centuries. And that justified true belief account, even though it's been challenged, is a great starting point. Multimodal logic gives us the tools to really analyze that definition, to
Yeah.
break it down into its parts, and to see how it relates to other concepts like justification and truth.
It's like taking something apart to see how it works. But then there are different ways to define things, aren't there? Something about syntactic and semantic definitions.
Yep, you're right on the money. Syntactic definitions are like coming up with shorthand within our logical system. So for example, let's say we have a multi-agent system, meaning we're dealing with multiple agents, like different people, each with their own knowledge. And we have separate symbols for each person's knowledge, like agent A knows or agent B knows.
Okay, I can picture that.
Well then, everybody knows that P can be defined as simply agent A knows that P and agent B knows that P, and so on.
So, like a shortcut to express a group's knowledge based on what each individual knows.
Exactly. But then we have semantic definitions, and those are a bit more complex. They deal with the underlying structure of our logical models, those possible worlds we talked about, and how they relate to each other.
So, we're digging a little deeper here.
Right. Think about the concept of distributed knowledge within a group. It's not just about what each individual knows, but what the group could know if they pooled all their information together.
Like the collective wisdom of the group, even if nobody individually has the full picture.
Exactly. And to define that semantically, we have to look at how all the individual agents' knowledge overlaps.
Hmm.
Basically, we say that a possible world is compatible with the group's distributed knowledge only if every single agent considers that world possible.
Ah, so it's about what the group can collectively rule out as impossible, based on everyone's combined knowledge.
You got it. And it gets even more interesting when we start defining beliefs in terms of evidence. There's this type of multimodal logic called evidence logic, which uses what's called neighborhood models.
Okay, this sounds like we're getting into some pretty technical territory.
Don't worry, it's not as scary as it sounds. Imagine an agent has gathered some evidence about different things. Each piece of evidence points to a set of possible worlds that are compatible with that evidence. And then belief isn't just about having some evidence, it's about looking at the most consistent combinations of that evidence.
So, like figuring out what makes the most sense based on all the evidence you have.
Exactly. And the cool thing is, this approach can even model situations where an agent's beliefs end up being inconsistent because their evidence is contradictory.
Oh, that's fascinating. Like when you have two pieces of evidence that seem to point in opposite directions.
Precisely. And then there are plausibility models, which add another layer of complexity.
Okay, bring it on.
Plausibility models allow us to rank possible worlds based on how plausible they are. This lets us define concepts like safe belief, which is basically believing something that's true in all the worlds that are at least as plausible as the current one.
So, like a belief that's pretty well supported, even if it's not absolutely certain.
Right. And then there's simple belief, which is believing something that's true in only the most plausible worlds. It's like saying, this is the most likely scenario, so this is what I believe.
Ah, I see. So we've gone from defining individual concepts to actually ranking entire possible worlds based on their plausibility. It's like building a whole hierarchy of how believable different scenarios are.
That's a great way to put it. And this ties in with ideas like sphere models and belief revision, which is about how our beliefs change when we get new information that might make certain worlds more or less plausible.
So we've seen how multimodal logic can help us define all sorts of philosophical concepts. But what about when we want to combine entire systems of logic? Like, can we take the logic of time and the logic of knowledge and put them together somehow?
That's a fantastic question, and it gets to the heart of what makes multimodal logic so powerful. There are a few ways to do this. One approach is called fusion. It's kind of like putting two Lego sets together.
Yeah.
You're merging the languages and the models of the two systems into a single bigger one.
So now you can talk about both knowledge and time within the same system.
Right. And then you can start introducing bridge principles, which are
Yeah.
basically rules that connect the two modalities. For example, in temporal epistemic logic, which combines knowledge and time, you might have a bridge principle like perfect recall. This basically means that if you know something at one point in time, you'll always know it in the future.
Ah, so it's a way to express how knowledge persists over time.
Exactly. And these bridge principles can have all sorts of interesting philosophical implications. Another one that's often used is no learning, which means that your knowledge can't actually increase over time.
Now that one seems a bit counterintuitive, doesn't it? I mean, we're constantly learning new things.
Yeah, and that's why no learning is often used as a kind of simplification in certain models. There's a related idea, though, called no miracles, which is a bit more nuanced. It basically says that you can't just suddenly lose uncertainty about something without a good reason.
Like, if I'm uncertain about what you had for breakfast, learning that it's raining outside shouldn't magically make me certain about your breakfast.
Exactly. The rain and your breakfast are unrelated, so learning about one shouldn't affect your knowledge of the other.
Okay, I'm with you. So we've got fusion, which is like combining two Lego sets. What are some other ways to put these logics together?
Well, there's also this thing called temporalizing or epistemizing a system. It's like taking an existing system and adding either a time dimension or a knowledge dimension to it. For example, you could temporalize preference logic to study how our preferences change over time.
That makes sense. Like, what I prefer today might be different from what I preferred yesterday.
Right. Or you could epistemize deontic logic, which deals with obligations, to explore questions like, do you have an obligation to do something if you're completely unaware of that obligation?
Oh, that's a good one. Like, if I don't know I'm supposed to take out the trash, am I still obligated to do it?
Exactly. It gets to the heart of what it means to have an obligation. And this kind of thinking can lead to some really interesting paradoxes, like the paradox of epistemic obligation.
That one sounded pretty wild. Like, if you're obligated to know something and knowledge means it has to be true, then it's like you're obligated to make it true.
Yeah, it's a real head scratcher. But that's what makes these multimodal systems so interesting. They can help us uncover these hidden complexities in our everyday concepts. Now, another way to combine logics is by taking their product. It's kind of like fusion, but with special interlocking bricks that create specific connections when you put them together.
So it's not just about putting two systems side by side, it's about how they interact.
Exactly. Product logic automatically enforces certain bridge principles by the way it constructs its models. And what if the classic examples of this is David Kaplan's framework for understanding indexical terms like I and now.
Okay, remind me what indexical means again.
Indexical terms are words that get their meaning from the context in which they're used. So I always refers to the speaker, but who that speaker is changes depending on who's talking.
Right, so I means something different when you say it versus when I say it.
Exactly. And Kaplan's framework models this using a kind of product logic that combines possible worlds with agents and times. So I am happy might be true in one world where I'm the speaker and false in another world where you're the speaker.
So it's about capturing how the truth of a statement can depend not just on what the world is like, but also on who's speaking and when.
You got it. And another fun example is Facebook logic, which combines epistemic logic with the logic of social networks. So you can have statements like, I know that all my friends like this post, where the truth depends on both what you know and who your friends are.
Oh, that's a great example. It shows how these logical systems can be used to model all sorts of real-world phenomena.
Absolutely. And finally, there's modal fibering, which is a bit more technical.
I'm ready for it.
Great. So in fibering, you merge the languages of the two systems, but their underlying models stay separate. And the key is that you have these transfer mappings that let you move between the models when you need to evaluate a modality from the other system.
So it's like building two separate Lego creations, but having specific bridges that connect them.
That's a perfect analogy. It's a more flexible way of combining systems than fusion or product. Okay, so we've got this toolkit of multimodal logic, and we've seen how to combine different systems to make even more powerful tools. But how does this all help us act as philosophers and tackle real philosophical problems?
That's the million-dollar question. Like, does all this logic actually help us make sense of the world?
Absolutely. The sources you sent were full of examples of how multimodal logic can shed light on some classic philosophical puzzles. Take Fitch's knowability paradox, for instance. It starts with this idea called verificationism, which basically says that all truths are knowable in principle.
Okay, so if something is true, it should be possible to know it.
Right. But then, using some basic logic, you can derive this crazy conclusion that if all truths are knowable, that all truths are already known, which of course doesn't make sense. There are tons of things we don't know yet.
That's where things start to get paradoxical, right? It's like our logic leads us to a conclusion that contradicts our common sense.
Exactly. And what this paradox highlights is a potential problem with the idea of universal knowability. Maybe it's not as straightforward as we thought.
So how does multimodal logic help us untangle this mess?
Well, one approach is to use dynamic epistemic logic, which introduces modalities for communication and information change. Instead of static knowability, we can think about learnability, whether a truth can be learned through announcements.
So it's not just about whether something can be known in principle, it's about whether we can actually get to that knowledge.
Right. And it turns out that not all truths are learnable in this dynamic setting. So multimodal logic doesn't necessarily solve the paradox, but it gives us a new way to think about it and a deeper understanding of the relationship between truth, knowledge, and communication.
That's really cool. So even if it doesn't give us a neat answer, it helps us ask better questions.
Exactly. And then there's the paradox of the perfect believer, which arises from the interaction between the logic of belief and the logic of knowledge.
That one was a mind bender, too. It's like, can you believe you know something without actually knowing it?
Right. It seems intuitive that you could, but if you formalize this using certain logical systems, you run into a contradiction. It turns out that the properties we typically assign to belief and knowledge, when combined, lead to some unexpected consequences.
So it's like our intuitions about these concepts aren't always logically consistent.
Precisely. And multimodal logic forces us to confront these inconsistencies and to refine our understanding of what belief and knowledge really are. And another interesting concept that came up was truth makers.
Yeah, that's usually thought of as a metaphysical question, like what in the world makes a statement true?
Right, but you can approach truth makers from a modal logic perspective too. Instead of possible worlds, you focus on states, which are kind of like snapshots of reality, and these states can verify or falsify propositions.
So it's about grounding truth in the actual state of the world.
Exactly. And you can define logical operations in terms of how these states combine. It's like giving a logical underpinning to the idea of what makes something true.
That's a really neat way to connect logic and metaphysics.
And then we have the Brandenburger-Keisler paradox, which deals with beliefs about beliefs.
That one was a doozy. It had something to do with someone believing that someone else believes something about their own belief, right?
Yeah, it gets pretty tangled. But the basic idea is that you have this scenario where you end up with a statement that's both true and false, depending on how you model the situation. And this suggests that there might be limits to how we can represent certain complex belief structures within our logical systems.
So it's like a paradox that pushes the boundaries of what our logic can handle.
Exactly. And it highlights the challenges we face when trying to model these higher-order beliefs, beliefs about beliefs about beliefs. It's a powerful reminder that our logical tools, while powerful, are not without their limitations.
Well, this has been a fascinating deep dive into the world of multimodal logic. It's amazing to see how these seemingly abstract logical systems can actually help us grapple with some of the biggest philosophical questions out there.
It's a testament to the power of logic as a tool for philosophical inquiry. And it shows that even when we encounter paradoxes and challenges, it's an opportunity to learn and to deepen our understanding.
So for you, our listener, I hope this has inspired you to think about how multimodal logic might be relevant to your own field of interest. Whether you're into technology, business, art, or even just everyday life, these tools can help you analyze complex concepts and to uncover hidden connections.
And if you're curious to learn more, definitely check out resources like the Stanford Encyclopedia of Philosophy. There's a whole world of fascinating logic out there waiting to be explored.
So keep those big questions coming, and we'll see you on our next deep dive.